In this segment, we will discuss the loop control variable, or the LCV. The loop control variable is the variable that we use to determine whether or not the loop should iterate. In this case, the loop control variable is InValue. InValue is getting a value from a user via the keyboard. If the user enters in valid data, this loop will continue to go until the user puts in -1. We talked about -1 being a sentinel value. A sentinel value is a value outside the data range and used just to terminate the loop. In this case, our sentinel value is a numeric value, but it can also be a string. We will see that later. And by the way, the sentinel value does not have to be -1. It could be -55, -7. We said that if we were entering in temperatures, -1 would not be a good candidate for a sentinel value because it could be included in the data set. So in that case, we would use something like -50, although in Bowling Green, we might use something even lower than that, like -70. We use the sentinel value to terminate the loop process by giving the LCV that sentinel value. So three things must happen to the LCV to have an efficient loop. The first thing is we need to initialize the LCV to a value before we enter the loop. Once we initialize the LCV, we then test it in some condition. If the condition is true, the loop iterates. If the condition is false, the loop terminates. And then finally, we must update the LCV inside the loop. If we don't give the LCV a new value, this loop will continue on forever. We refer to that as an infinite loop. An infinite loop is a loop that cannot stop on its own. Usually, if you have an infinite loop, you can hit a certain set of keys on the keyboard like Control Escape or Alt Escape to terminate the loop process. So again, the three things that must happen to the LCV: we must initialize it, test it, and then update it. Let's look at some of the code we went over in class and identify the LCVs for the various loops. In this case, it's easy to identify N as the LCV, but let's see if the three things are happening to it. Yes, it's being initialized, we are testing it, and then we are updating it inside the loop. So initialize it, test it, update it. In this case right here, let's see what the LCV is. Is the LCV the sum? We are initializing it, we are updating it inside the loop, but we are not testing it. So sum is not the LCV. What about K? We are initializing it, we're testing it, and we're updating it. So K in this case is the LCV. In this case right here, the LCV again is the only variable that we have, B. We initialize it, we test it, and we update it in the loop. So it is the LCV. Can you see what would happen if we deleted this statement right here? If we deleted this statement, we would not be doing the three things we need to do to the LCV. We would only initialize it and test it. The update would not happen. If the update doesn't happen here, this loop will continuously print b equals 2, b equals 2, and it will do that until we figure out some way to manually stop the loop. This loop would be an infinite loop. Take a look over here and see if you can tell which variable is the LCV. You're right. Large and small are both the LCVs. Small is being initialized, it's in the test, and it's being updated. Large is initialized, it's also in the test, and it's also being updated. So large and small in this case are both the LCVs. Here's a document of code that I put in your packet. It's document E2, and it is full of examples that we've either gone over in class or that are modifications of code that we went over in class. For problems 4 and 5, let's see if we can identify the LCV. For number 4, what is the LCV? We have variables day, best distance, and distance as candidates. A simple way to figure out what's the LCV when we're using a loop control variable is to first look in the test. In the test, we have distance. So now let's see if distance is getting initialized and updated inside the loop. Distance is getting an initial value before the loop, and it's being updated inside the loop. So distance fits all the criteria to be the LCV, the loop control variable. Let's look in this example. We have variables winner, score, winner name, and name. Let's see what the LCV is. Again, the best place to look first is in the test. Name is in the test. Is name being initialized? Yes, it is. Is it being updated? Yes, it is. So it turns out that name is our LCV in this problem. And guess what? Q is the sentinel value. So in this case, we don't have a numeric sentinel value, but instead we have a letter that the user is going to enter in to quit the process. The way we've structured our loop is that the user can put in an uppercase or a lowercase q to terminate the process. This describes how to identify the LCV.